Welcome to another session of Everyday Mathematics. Here at Everyday Mathematics, we say we do enjoy solving the harder problems, but also we do appreciate and see the beauty in the simple problems. So today, we shift gears. Last week and previously we were looking at the qualifying exams for the MIT 2022 Integration B, focusing on trigonometry. We also looked at questions in the finals, semi-finals, and quarterfinals. So today we are moving forward to the regular season competition. I'm going to focus on one problem. Why? Because it's very interesting and we didn't want to take a lot of the amazing star in the problem. So we focus on one problem today, and that is problem number 3. Which is the integral from x is equals to pi over 2 minus 1 to x is equals to pi over 2 plus 1 for cosine of arc sine or arc cosine of sine x. Very interesting problem. And before I quickly jump into the solution, I would like to just thank our subscribers. We are really growing. We've crossed the 300 mark subscriber point, and so we're excited. We're growing, and we enjoy this. We do enjoy this. We thank our subscribers. We don't put that support for it. If you're here for the first time, we really appreciate your subscription. Please consider subscribing to our channel. If you're here for the second part of time or beyond and still haven't got the confidence to do so, please consider subscribing to our channel. So going on to the solution of the problem. This problem is obviously unique, and I do like to express the arc sine and the arc cosine in a different way, using to the power -1, because that's how I grew up learning how to express these functions. So if you look at the sine term here, and you look at pi over 2 minus 1 and pi over 2 plus 1, these are equal. As regards sine. So it means that for the function sine, because that's the root of this function, it is symmetric about pi over 2. And so for problems like these, it's very important that you split it so that you solve twice the half of that function of the domain that is under consideration. Otherwise, you will come back to a point where you substituting these limits that are equal, and you get stuck. So what I've decided is I'm going to look at the lower half and multiply the entire integration by 2. So I'm going to integrate from pi over 2 minus 1 to pi over 2. And then multiply the entire integration by 2. So first I'll begin by saying let u be equal to arc cosine of sine x, in other words, this term here. And so what that means is that cosine u is equals to sine x, such that negative sine u du dx is cosine x. And so negative sine u over cosine x du dx is equals to 1. And so we can express cosine x in terms of u by converting cosine x into the square root of 1 minus sine x squared, sine squared x. And that means that now that is sine u over 1 minus cosine squared u, since here cosine u is equals to sine x. So 1 minus cosine squared u is sine squared u, and so that becomes negative sine u over sine u du dx. And so, in other words, since the sine u and sine u cancel out, we have du dx is equals negative du dx equals to 1, and therefore negative du is equals to dx. So, and also, since cosine u is equals to sine x at the limits when x is equals to pi over 2, cosine u is equals to pi over 2 plus 0, and therefore cosine u is sine pi over 2 cosine 0, and therefore, since the cosine pi over 2 on this end, I forgot to made a small mistake here, so this is 0. So this entire time goes to 0, and so this goes to 1, and so we have cosine u is equals to cosine 0, therefore u is equals to 0. Okay, and then when x is equals to pi over 2 minus 1, cosine is equals to sine pi over 2 minus 1, and so using the formula for the sum or difference of angles, we have cosine u equals to sine pi over 2 cosine 1 minus cosine pi over 2 sine 1. And therefore, cosine pi over 2 it tends to 0, and this tends to 1. So cosine u is equals to cosine 1. And so u is equals to 1. So now we're substituting our equation here. So it becomes, this initial integration is twice. The lower limit has now been found to be 1, and the upper limit is 0. And then cosine, arcsine, u is in place of arc cosine, sine x. And so the negative here comes from the dx being equal to negative du. And so we have twice of that. So when we have a negative sign, we need to cancel this out. We can now flip the limits. So 0 goes below from up to lower, and 1 goes up. And then I mistakenly left negative here. So the next step is by letting y equals to arcsine u, such that sine y is equals to u, and so cosine y is equals to dy du. Cosine y dy du is equals to 1, and so cosine y dy is equals to du. And then the limits 0 and 1 at 0, arc sine of u at 0 is 0, arc sine of pi over 2 or of 1 is equals to pi over 2, and so twice cosine arc sine u from 0 to 1 is the same as twice, since this part inside the cosine function is y, is cosine y, and then since we found du is cosine y dy, so cosine y dy. So this is twice the integral from 0 to pi over 2 of cosine squared y, and that means that now we have twice the square of that. We can convert that to a double angle expression, which is a half cosine 2y plus 1. And so this half and 2 here cancel out, so we have 1. And the integration of cosine 2y is half sine 2y, and then 1 is y. So from 0 to pi over 2, we substitute the limit, and then we have pi over 2, because sine 2y of, we place pi over 2 in place of y is 0, and 0 is 0. So this y here becomes the remaining variable. And so pi over 2 minus 0 is pi over 2. This is our final answer. Thank you so much for hanging around with us. It's been certainly an interesting problem. And so I hope you also enjoy the solution.